That's right, friends. Check them out, the new specs. These are the anti-blue light reading internet computer screen glasses. Hey guys, welcome back. Recently I had you work on some geometry problems involving angle relationships. Let's take a look at some data and some example problems to see how we can improve with this math. Let's get into it. Alright guys, let's take a look at this example on complementary angles. Complementary angles, of course, are two angles that add up to 90, which means they form a 90-degree angle or a right angle, okay? So if we look at this picture here we go, we see they've identified a right angle right here, right? Angle 3, that's a right angle. So that's not what they're asking. They want complementary, specifically to angle 1. Where's angle 1? Right here. Okay? Now it's multiple choice. Angle 1 plus what will equal 90? What are our choices? Angle 1 plus 5. Oh, 5's too big. 5's 90 itself. That can't be it. Angle 2. That's probably it, right? Well, let's just take a look. That would make a 90. You know? Hopefully you guys can see that. Angle 4. Nope. Let's clean this up a bit if we can. Okay, angle 4. Is that one? No, that's 90 itself. How could that be complementary? It's two angles that equal 90. This is one angle that is 90. That's not it. Angle 3. Well, we just said, we started off by saying that's 90. So guys, it's got to be angle 2. It's the only one that really makes sense. You got to break it down. Next. Alright guys, check it out. We have example 2. This is also on complementary angles. Alright, now if I'm a struggling student, I may need a different approach. Maybe we should draw a picture, right? As you guys are doing work, you should have a notebook. So in my notebook, you could always draw the picture. Right? It's never going to look exactly like this, but let's just number it. We have 1, 2, 3, 4, and 5. Break down your picture, right? What do we see? Angle 1 is a right angle. We also see we have a straight line here. Straight line is 180. There's another straight line here, 180, right? What's the question? Which angles are complementary to each other? So now they've given us, check it out, pairs of angles. Which one's complementary? Let's run through the options, right? So, 2 and 4. 2 itself is a 90-degree angle. And it doesn't look like it in my drawing, right? But 2 is a 90-degree angle. So anything involving 2 cannot be right. Because it's two angles that add up to 90, right? Not one angle. What's our next choice? 4 and 5. Well, 5 is also 90, right? 5 itself is 90. So this is like 90 plus whatever this is going to be bigger than 90, right? So it cannot be this one. It's got to be this one. We haven't even checked it out yet, but let's check it out. 4 and 3. Absolutely. This piece, number 3, with this piece, right? Number 4. We put them together in total, yes, this is a 90-degree angle. Okay? Another way to think about this. Let's clear this off. Another way we could think about this. I realize we might be struggling because these diagrams are getting more complex. It's not just one or two lines, right? This thing has lines in every direction. So it can be confusing. You gotta draw the picture, okay? And then break down your picture. You're gonna draw a picture, and we'll really try to break things down, okay? This is what we have in this problem. Imagine a circle on top of this. What do you know about a circle? A circle is 360, right? Imagine a circle on top of this. They're telling us angle 1 is 90. So that's 1/4. So we know 1/4 of 360 is 90. Right? Well, what else do we know? Since this is divided into 4 spaces equally, this is also 90. This is 90. This whole section must be 90, right? Okay, guys. Now, this next example asks us to work with vertical angles. What are vertical angles? Right, you can check out my last video where we covered that and review that. But vertical angles essentially open opposite to one another, and they share the same vertex, right? That common point. So in this problem, the vertex is F. Point F is the vertex, okay? And let's kind of start breaking down this picture. As we see these math problems, and notice this is actually a 7th grade math problem. Interestingly enough, this is a 7th grade problem. There's a lot of lines here. This could be very challenging for a middle school student. You have to find your baseline, your 180. Remember, a straight line is 180. So where are the straight lines? We see BFD. Right, you guys see that? BFD. That's a straight line. That's a key line right there. Okay? Now we have this other one. AFC. Okay, now let's read this question. Now there is another line. We should just add that too. And this is what? E? Okay. So we have these two straight lines, and then this other kind of line thing, FE. Okay. Which angle is vertical to angle DFA? So let's identify where is DFA. So let's figure it out. D to F to A. DFA is a big angle, right? It contains this little angle in it, DFE. So this is DFA. Let's actually change our color and we'll mark that off. DFA. That's DFA. Which angle is vertical to this? Right? Now we have to use a picture with vocabulary. So you have to know the definitions and we have to be able to interpret a picture. So there's a lot of different skills going on with this type of math, right? We interpreted the picture. Now we need to use the definition of the word. Vertical angles, two angles. They open up opposite. So where currently DFA is opening this way, right? We need something that's going to open opposite to this. Something in this direction. Right? So let's look at our choices. Use the multiple choice, right? That's a problem-solving strategy in itself. One of these is the answer. We have a 25% chance, so don't give up. We have angle AFB. AFB, that's down here. That's not the definition of vertical. It does not open opposites. CFE. CFE, no way. That could not be right. What does that have to do with the vertical angles? BFC. BFC. Aha, that's looking like the winner, but we have to examine all choices. EFB. EFB. Nope. That is not the definition of vertical at all. I don't know what that is. So there you go. That's how you do this type of math. You need to break it down, draw the picture, and know your vocabulary words. Good luck. You can do this. Okay, this will be our final example. IXL said you guys struggled with this type of math, and I can see why. Look at this. It's like a tic-tac-toe board or something. There's a lot going on here. Half of the alphabet is spilled out on this problem, right? All kinds of letters and points. Let's break it down and see what's going on. The first thing we notice is that this is a truly legit 8th grade problem, right? We're looking at complementary, supplementary, vertical, and adjacent, which involves, of course, congruency. So these are the themes we need to use to answer this question. What is the question? Which angles are vertical to each other? Okay, so vertical. Okay, we're looking for things in an X. Vertical angles, they share a vertex, and they open opposite, right? So they're vertical. So look for the X's within the bigger problem, all right? That's part of the keys to this type of math. There's all vertical angles sprinkled in. You just got to find them. Once you kind of see that concept, let's break down the choices. It's multiple choice. If you read through the choices and really think about it, you can do this math. Let's look at these different choices, okay? ECH, where's that? ECH. Finding it is half of the battle, right? And there's ECH. BHF. BHF. Huh. Do those angles share the same vertex? No, so they're not vertical angles. Next. Okay, next we have HBE. Break it down. H, B to E. That's right here. Okay. KCL. K to C to L. No. They do not have the same vertex, right? Speaking of vertexes, or vertices, I should say vertices is the plural way to say it. When we look at these so-called 3-letter codes, the middle letter is the vertex. So vertical angles, by definition, has to have the exact same middle letter. So these would have a chance. Notice, these did not have the same middle letters at all. C and H, right? They're not the same. Okay, so let's check it out. CHB. CHB. That's this one right here. And GHC. And GHC. G to H to C. Now these are getting closer. Looks like they share a vertex. Do they open opposite? Look at these diagrams, right? We're looking for opposite action. These aren't really opposite over here. So That's not it. So we think it's this one by default, but we need to truly examine it, right? And let's look at it. We have BEC, which is where? BEC. And DEA. Oh yeah. That's definitely it. Right? You see the X is that X diagram. The common vertex is E. And these open opposite to each other. Right? This is kind of going diagonally down. This one's sort of going diagonally up. There you go, guys. Vertical angles, angle relationships. You can do this math and be great at it. Good luck.